So my job is very limited, very restricted here. I have been directed by the student organizers to introduce the panelists for this particular session. Um, Here we go. We have Professor Jaisalan from EFLU, Hyderabad. He's also very lovingly known to us as Jay, but mind you, he's not the Jay from the Viru Jay fame of Sholay. Um, Professor R. Jay is a linguist. He's a very well-known generative syntactician, theoretical syntactician who's worked on multiple languages, multiple aspects of languages, and his works have shown us how we generate sentences using a rule-based system, a grammar machine, right? Which we assumed is there innately in the minds of native speakers. But in more recent work, he has also shown us that this generative machine, this grammar machine, can be reduced to a minimal grammar with very few computations, which are enough to produce legible structures for the interfacing cognitive modules. So maybe thought module and the system that allows us to externalize speech. Right? So when we had to choose, actually when the student organizers made the decision, um, or when they were looking around for speakers for this particular topic, computations in language, it was very easy to narrow down on his name because he is the one who will give you a clear picture of what is happening in that field. But we also had very little, we did not really take long to decide on the second panelist, Professor Sumit Agarwal. Um, we decided on him because he is a multifaceted person also, as I will tell you. Sumit, what is interesting about Sumit is that he's not a linguist, right? So he has a job as a faculty member in the Department of Electrical Engineering by day, and by dusk, by nightfall, he turns into a linguist and a philosopher. So unsurprisingly, we have many common research interests. He particularly is interested in issues of artificial intelligence. He wants to find out what are the mechanisms underlying intelligent behavior in human beings. And he also, whether rule-based systems like the ones that we generally espouse are adequate enough to account for intelligent behavior, for behavioral patterns of all kinds, or whether we should also look at neural networks and cognitive connectionist models to work out some of these patterns. Right? So with that, I'll leave the floor open. I think they have enough interesting things to tell us about computations in human language, whether we should proceed with rule-based systems or connectionist models, or if they can be bridged together at some point. So with that, I'll leave the floor to them. I welcome Professor Jaisalan, first of all, to speak for 20 minutes, followed by another 20 minutes by Sumit. Oh, I haven't finished. And then we'll leave the floor open for questions.
Okay, I'll come up there
You want
because
to come up?
yeah, I can use the podium. No, I got this. I think my mic is working. Yeah. Thank you for inviting me and giving me this opportunity to come face to face with computational people who are working on language processing. uh, what I'm going to do is I'm going to take a kind of historical perspective on how our ideas in linguistics developed in the last 50 years or so. And as we know, Chomskyan linguistics, Chomskyan generative grammar distinguished itself from traditional grammar and also from other contemporary rival theories of linguistics like the structuralist linguistics of Britain and America by starting from mentalist claims. That's how it first differentiated it. Okay? And the most important mentalist claim was the claim about there being a universal grammar which the human child is born with. That's the innateness hypothesis. But what I want to stress is that the so-called mentalist claim was also a physical claim, because Chomsky always talks about mind brain, mind slash brain. He never talks about mind alone. So when we made this uh, so-called mentalist claim, we were also claiming that the the universal grammar is represented in the faculty of language is located in a certain part of the brain, and therefore there was naturally an expectation that UG would be physically realized in the brain. Okay? Now, brain research has not found anything like UG in their investigations, but that's natural enough. For one thing, brain research is still in its early days, but more importantly, from our point of view, our views about uh, language, about UG, were very unsophisticated in the early days. Our views had to evolve. And that's what I'm going to uh, talk about, this historical way in which our views about UG evolved over the years. Our early conception of the principles of UG were as things which were very particular to language. That is, the principles of UG were, as it were, isolated in the mind brain. UG kind of existed in a kind of modular isolation in the mind brain. We never made any attempts in those days to connect it to anything else. Although we always knew that uh, the modularity of mind assumed that there was interaction, but we never focused on that in the early days. We did not in those days have any conception of what sort of thing would qualify to be a principle of use. If any constraint, for example, could be shown to apply across many languages, we immediately elevated it to the status of being part of use. Uh, this was especially in 1965, the aspect stand. And when theory of government and binding came, all the subcomponents of GB, like, for example, case theory, binding theory, bounding theory, etc., all these were assumed to be, naturally assumed to be part of UG. That was the assumption. And take, for example, the bounding theory. The bounding theory is a theory about why we cannot extract a subphrase from certain syntactic configurations, like, for example, the iron constraints, etc., etc. And why we cannot, for example, from adjuncts, you cannot extract. And we try to account for it by postulating something called a bounding node. You remember that from your GB days? Bounding node. And then we debated in linguistics about what this bounding node could be. For example, it was suggested in the early days, it was debated in those days whether S or S bar was the bounding node. It was claimed that S bar is the bounding node in Italian, S is the bounding node in English. These kinds of ideas, you see, are extremely language particular. It's very difficult to relate it to anything outside. And the distance of these kinds of ideas from any kind of physical realization in the brain was far too distant. That is, the, the distance was unbridgeable between the kinds of things which linguistics was talking about and what brain research could possibly find. So that is the early picture of UG that we had, which made it impossible for us to relate to anything outside linguistics. Now, what I want to say is that linguistics has since changed. Minimalism you can think of as a kind of watershed, because one of the first things that minimalism insisted on was that all the principles of language have to be accounted for in either of two ways. Either one, as economy conditions, that's conditions about uh, computational economy, or as legibility conditions imposed on the language faculty by the outside systems with which it interfaces. Okay, that is one of the first things which the first minimalism paper says, that uh, 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 linguistic principles have to be accounted for in these terms. Only two ways, either economy conditions or as legibility conditions with respect to outside systems. Uh, what are these outside systems? That is, for example, an utterance has two aspects to it. There's a sound and there is a meaning. Okay. On the sound side, the utterance has to interact with the physical mechanism of the articulatory mechanisms of the body, the tongue, the lips, the larynx, etc. Now, these are physical organs which are not dedicated to language in any way. Far from it. The primary function of the tongue is to eat and not to utter sentences. Okay? So, these are physical organs which we have co opted for the use of language. Humans have co opted for the use of language. But those physical organs come with their own constraints. So, for example, if an utterance requires a segment of sound that asks for the tongue to be both high and low in the mouth at the same time, the physical mechanism says we can't do it. So, okay, so these constraints have to be met. Similarly, think of the other aspect of any utterance, namely meaning. Meaning has to be the kind of meaning which linguistics outputs has to be interpreted by the meaning making part of the brain. But the meaning making part of the brain, again, is not anything which was primarily meant for language. Its primary function is to make meaning of the world. Otherwise, we cannot live. That's the primary function of the meaning making component of the brain. And we have just co opted it for interpreting utterances. And that component, when it interfaces with language, it tells the utterance, look, if you contain, say, a variable which is unbound. Okay, 10 minutes, okay. A variable which is unbound, I cannot interpret it because its reference cannot be determined. The meaning making component, meaning making part of the brain requires reference. And an unbound variable is something whose reference cannot be determined. Therefore, it says I cannot interpret it. So these are outside systems which impose their conditions on the language faculty. And by insisting in the beginning of minimalism that the language faculty has to accommodate its principles, has to derive its principles from, at least partly, from these interactions, Chomsky in minimalism brought UG out of its modular isolation. That's what he did. That's why minimalism is such an important step, because it brought UG out of its modular isolation. Uh, those who have sort of, you are all sort of, many of the students have uh, started learning linguistics with minimalism. You didn't go through GB, etc., etc. But for those of us who are older, who went through this entire process, we know that much of the stuff which we learned with great effort in GB, that has been jettisoned, okay, in minimalism. For example, this bounding theory, which I talked to you about, the bounding node, etc., all that has been quietly forgotten. Nobody talks about it. Okay? So, how do we account uh, for the facts which bounding theory dealt with? That, for example, you find it's difficult to extract something from within an adjunct. Now we say that, I mean, one of the explanations, there are several explanations. One of the explanations is that an adjunct is already spelled out when it is merged in the derivation. Already spelled out. That is, an adjunct is merged as a chunk. Now, imagine what this means for the derivational memory. The derivational memory is a short-term memory which has to keep in it, while it is producing this utterance, several bits of facts. Now, if a long and complex adjunct is merged as a chunk, it is in effect a word. And therefore, the derivational memory at that point no longer has to worry about the constituents of the adjunct. That is the internal structure of the adjunct. It, it results in a great saving of memory. So you see how the tenor of explanations goes now. We are going towards explaining linguistics in terms of saving memory, computational memory. Similarly, Chomsky in 1998, the Minimalist Inquiries paper, he proposed a theory of phases. The theory of phases says that an utterance is spelled out in chunks, small chunks called phases. After a phase is spelled out, it is treated as a chunk, and the derivational memory no longer has to worry about its internal structure. This again is a device, a way of organizing the grammar. Organizing the grammar, which whose purpose is to save derivational memory. So all our effort now is to find ways of explaining linguistics in terms of either interface conditions or in terms of computational efficiency. Since in a paper called Beyond Explanatory Adequacy, and since then Chomsky has been talking about 3 factors of language design. 3 factors of language design. The first factor, which he's going to say ought to be negligible and nil, is the kinds of things which are particular to language. Particular to language. That is factor 1. Factor 2 is what we talked of as interface conditions. That is trying to meet the requirements of outside systems which interact with language. And the third factor is computational efficiency, ways of minimizing computation, minimizing the length of wiring. And latterly, factor 3 has been becoming more and more important. An explanation, one way of, if you're giving an explanation in a conference, one way of sort of promoting your explanation is to say, look, this is a factor, third factor explanation, third factor consideration. Okay? So these are the 3 factors of language design, of which 2, interface conditions, and 3, computational efficiency, are taking over linguistic explanation. And Chomsky says that factor 1, namely things which are particular to language, ought to be negligible or nil. Okay? Negligible or nil. So we are now in a phase where the UG is explained away in terms of the principles of UG are explained away in terms of other factors which don't belong to language per se. And since minimalism, Chomsky has been steadily moving towards a brand of linguistics which he loves to call biolinguistics, okay, which is a linguistics which is based in biology. And with this development, if we go further on in this direction, linguistic theory ought to be able to shake hands with brain research. At the end. Okay, yeah, I'll get
So if you have questions that you want to address to Jay, you can note them down now, and then we'll discuss them after Sumit's talk. So now I invite Sumit to talk about computations in language.
So thanks very much to the organizers for giving me this chance. I've never spoken before a linguistics audience before, so slightly nervous. But I guess my job here is to kind of give an outside perspective. And already, I mean, from Professor Jayashilan's talk, I didn't know too much about minimalism as such, but one thing I can sense is that the kind of convergence that I want to try and suggest here between sort of traditional linguistics and what has been called connectionism, or these kinds of more neuroscientifically grounded ways of thinking, is already happening, and even the Chomskyians are moving in that direction. So I think that debate is anyway getting diffused, and I just want to, from a kind of computational perspective, suggest some ways in which we can think of these debates as really just being different perspectives on the same system, and not really being incompatible with each other at all. Right. So this first slide, I've just tried to kind of in brief lay out the sort of thesis that I'm suggesting, which is that I mean, if you think of the computations that are involved in language production or comprehension, so the rule-based, the syntax-based kind of way of thinking about it is that you have sort of generative grammar, and so basically it's symbol manipulation, right? You have a set of rules, and they produce strings of symbols, or they process strings of symbols, and then of course you have the semantic aspect which associates meaning. So you think of this as a kind of program or a piece of software. The best way to understand or specify this is in terms of these kinds of rules. So context-free grammar would be a simple way to do it, which of course in computer science also is very widely used to specify the structure of programming languages. And by the way, the fact that we have programming languages which we use to write computer programs, which have been developed in this way, and which are now at a level of sophistication that they in many ways are able to express things similar to natural language, that tells us that yes, this is we actually have engineered systems that reproduce some of the properties of natural language. So that is a valid kind of way of thinking about it, right? But then, so the question again is, how do you connect that to what we know to be the physical realization, which is the sort of network of 100 billion neurons sitting inside our skull, right? So we assume that that is sort of the hardware in which this is happening, and we would like to somehow try and understand how these concepts of symbols and syntax and rules emerge from these kind of neurons, which are basically just sort of units connected by synapses, where electrical signals flowing between them and so on. So this gap is what we would like to try and bridge in terms of understanding computation. You want to understand both the kind of physical layer of it and the sort of conceptual layer sitting on top of it. So I think the sort of debate between connectionism and uh, what is sometimes we'll call computationalism or the rule-based kind of view, in some ways has been a red herring, because it has sort of suggested to many people that these two views are somehow at odds with each other, whereas I think the suggestion here is just that there are different levels of abstraction uh, for the same system. So, yeah, and one important aspect of this debate also has been the debate between sort of innateness versus learning, and people have often associated connectionism uh, with sort of very little or no innate sort of language specific kind of abilities, right? So this idea of the tabula rasa, the blank slate, has often been associated with connectionism, the thought being that the connectionist approach is saying that everything is, these sort of connections between neurons and so on are all learnt, and so you are not kind of born with anything to begin with. But we now have in practice many kinds of models which are being used in all sorts of engineering applications, which combine certain innate properties or constraints with learning, right? So we very well know that in these connectionist models it's possible to have both. It's not that you have to learn everything. You have certain constraints on the way these things can be wired up, on the kinds of properties they have. So you have some knowledge in some sense hardwired or embedded into the structure of the system, and then you have other things which can be adjusted, which can be learned, right? So it's a mix of both, and that can surely capture even some of the earlier ideas from the Chomskyan kind of framework, principles and parameters. I mean, it's the same kind of thing. You can realize that in these connectionist models also, and so the universal grammar kind of idea, right? That would, in this way of thinking, be some sort of uh, prior conditioning on the way these networks are wired up, which then make it easier to. So if you start completely from scratch, you don't get enough data to sort of be able to learn language, right? That is the classical poverty of stimulus kind of argument. But you would be able to do that if you have uh, some prior knowledge embedded in. So that was the idea behind universal grammar, and these models also allow you to encode that in some ways, right? So the, the the sort of faculty of language kind of idea, I guess, uh, again, depending on the level of abstraction you are thinking of. So, and clearly minimalism is also moving in this direction, that it's not sort of something which is isolated from the cognitive apparatus in general, right? So perhaps a better way to think of it is that it's like a specialized kind of piece of software or a program or an application which is doing this, but which is of course running on the same kind of architecture or system, which is also being used for a number of other things. And of course a lot of these things have been co-opted into language. They may have initially been evolved for other functions as well. So yeah, so this way of thinking is what I'm going to talk about. And really I don't have a lot to say, because in terms of research I think there isn't that much that has, so this gap still remains, right? But I'm just going to try and give a few examples which suggest that this might be a productive line of inquiry to go deeper into. So this is just a very simple example taken from Steven Pinker's book How the Mind Works, which is trying to show how, so just illustrate what I mean by these kind of neural network or connectionist models, and ways in which very simply these can encode more abstract kind of symbol manipulation uh, sorts of things, which you might think is coming closer uh, to what we think of as generative models for language, right? So this is I mean each of these pictures, so each unit here is sort of what we are thinking of as kind of a model for a neuron, and the idea is that it sort of takes inputs from other things, and then it adds them up. So let's just, in this example, let's just adding them up simply, right? So this unit is, let's say, taking, so think of each of these as being like a switch, right? So it's either on or off, and you multiply the value here, which is 0 or 1, with this sort of weight here. So supposing both of these are on, then you'll get 0.6 plus 0.6, which is 1.2. and then each neuron has a kind of threshold. So if the value coming into it is above that threshold, then it switches on, then it fires, otherwise it doesn't, right? So here you can see that if either one of these two you switch on, this gets a value of at least 0.6, which means it is above the threshold, so it fires. But if both of these are off, then of course the value is 0 and doesn't fire. So what this is doing is it's implementing a kind of OR operation. That is, if either this or this is true, think of these as kind of representing some sort of binary variable, then the output becomes true. Similarly, by changing these, you get a sort of AND condition where both of them have to be switched on to get the output. You can get a NOT condition where the output is the opposite of the input. So this kind of uh, modeling has existed for the last 40 or 50 years, and you can do much more sophisticated things with these networks. You can combine these smaller units into bigger sorts of networks of these things and implement much more sophisticated computational operations. But the thought is that this kind of example just illustrates how starting with something which is grounded. So the idea of these units is grounded in what we know about how neurons actually work, which is that a neuron has these synapses coming in from other neurons, and these electrical signals are in some sense integrated here, and then there is some activation threshold above which the neuron fires. So it's not exactly that it's a switch, but in practice, effectively there are only two relevant levels. Either it has a sort of high voltage or a low voltage. You can think of it that way. So yeah, so this is a model that approximates the key features of what we know of how neurons work, and then you can use that to build up these more abstract kinds of logical operations. And the thought is that you may be able to generate behavior which resembles sort of generative grammars, for example, using as a basis these kinds of simple models, and that would give us some insight, hopefully, into how the brain actually is achieving that kind of computation. Okay, so one other reason why you might think that it's useful to also take this sort of lower level view of language and trying to understand how these computations happen is that there seems to be a lot of sort of fuzziness or noise in some ways, variability in the ways in which both language comprehension and production happen, and there's a lot of sort of robustness built into the system in some sense. So these are just two simple examples of different kinds. I'm sure you've come across these kinds of examples, so I'm sure you can all easily read this sentence. But if you look at it carefully, you can see that except for the first and last letter of each word, all the other letters are in the wrong place. So you might think, how is it that I can so easily process this sentence, even though on the face of it, the sort of rules of spelling or morphology are being violated to such an extent? So one way to perhaps understand that is that while at a higher level, we are able to capture what is happening in terms of these rules, but the actual sort of neural or hardware implementation uh, is sort of more like recognizing certain kinds of patterns, right? And so that means that the rules are kind of an approximation to the pattern recognition happening at the lower levels, but that recognition ability is quite robust to these kinds of noisy elements, which is hard to kind of understand if you think of it purely as a formal rule-based system. So this is a visual example where so you interpret this as the word mind, but this could just as easily, behind these blotches there could be anything. There could be other combinations of letters. This could be an H, for example. This could be a B, right? The part of the letter you can see is equally compatible with these, but you are filling in the missing information based on your prior sort of frequencies of things that you have observed, essentially, right? So you have a kind of probability distribution over what this might be, and that distribution favors the word mind because that is what you have seen so often, right? So there's this kind of pattern recognition aspect to these tasks, which seems to fit well with the neural network kind of view. And in fact, for this example, people have actually developed these computational models that can take this as input and output the word mind once it has been trained on standard English text. So yeah, so this idea again seems to suggest that we may not want to think of it purely as rule based. I mean, rule based models are perhaps an approximation that capture a lot of the interesting behavior, uh, but the underlying implementation also may have these additional aspects. And if you think of language acquisition also, uh, so in the natural way of acquiring language, nobody normally tells us what the rules are, right? We may learn grammar in a formal way later on in school, or we may not. I mean, people speak language even if they have never been to school or been formally educated. So if you think of how language is acquired, it's clearly some kind of learning process based on the frequencies of listening to different words and different combinations of words and different structures, right? So your acquisition of language, I mean, most people do not even consciously know what the rules of grammar are, right? But they are perfectly well able to sort of distinguish between grammatical and ungrammatical sentences. Plus, they are able to deal with these kinds of noisy things, right? So these rules are sort of embedded into our brains in some way, but it's not that the rules themselves are explicitly there or known to us, right? So what seems to be going on is something more fuzzy, which these kinds of models, I think, give us some insight into. Okay, so I think this is kind of the last example I had, which is, I mean, I'm sure the linguists will be able to point out various problems with this, but this is just a very simple uh, attempt to make a connection, which really, I came across this idea on this blog, so I just thought it would be interesting to mention this, that so this merge operation is supposed to be one of the key elements of of the minimalist machinery, and so of course this is framed at the level of sort of manipulating syntactic structures, and it's thought of as the sort of key to recursion, which is a property that kind of distinguishes language from abilities that you find in, for example, non-human animals. So if you think, well, can I how would I get something like the merge operation in my kind of connectionist way of thinking? So there's a recent paper where they have suggested a particular kind of this neural network sort of model where uh, you have these sort of association units. So typically in that kind of picture I showed, those and or things, the number of inputs to one thing is fixed, and so you decide in advance that these are the number of inputs this is going to get, and then you try and learn the weights on those things based on data that you are getting. But in these models, you are able to deal with multiple varying numbers of inputs, and you have something called an association unit, which is able to sort of merge I'm using in the normal English sense, so it's not necessarily suggesting that it captures the properties of this merge, but it's able to merge two inputs into one, right? And so the thought is that this kind of thing would build up a sentence like this, sat on the mat, by kind of having these intermediate units which would combine inputs that would fire, let's say. So this would be like a unit that gets activated in response to that particular word. So just to say again, I'm not presenting any of the details here, but this is just to say that there is this kind of idea that you can obtain recursion. So in fact, this kind of model is called a recursive neural network, and by sort of and the connections between this and the sort of minimalist ideas really have not been investigated at all, and maybe this is one kind of thing that is an interesting research problem to look at. Uh, but really, to sort of summarize what I'm trying to say, uh, it's just that the symbolic computations of language that minimalism has been sort of so successful at explaining in many ways. One way to think of how they connect to the brain is that they may emerge from the kinds of connectionist architectures that also we have now started to get a handle on being able to model in very sophisticated ways using these large-scale neural network models, which are now in fact being used in a lot of artificial intelligence systems which have amazing vision and language capabilities. You might have heard of this computer developed by IBM, Watson, which was very successful at this Jeopardy uh, American game show, sort of this question answering game show. So that essentially uses highly developed versions of these kinds of neural network models, deep neural networks as they are now fashionably being called. So yeah, so I think that's kind of what I had to say. It's yeah. Again, just to summarize, the thought is that we sort of have language as a kind of emergent property of the brain, something which uh, the way we experience it is not directly relatable to what we know about the sort of nuts and bolts of the brain itself, uh, and so there can clearly be different levels of abstraction at which we understand this thing. Just like uh, in most sciences, you have this kind of idea. If you have looked at economics, you have macroeconomics, which is very useful at understanding relationships between sort of economic variables at a higher level. But you want to connect that to sort of the micro foundations, and this is an enterprise that is there in economics. In biology, you have many different levels of looking at how things work, starting from genes and then up to cells and organs and so on. So yeah, so I think so language is sort of the kinds of linguistic formalisms that we have come up with are capturing a level of abstraction uh, which is uh, which is at the level of emergent computations, and if we can understand better the connections between that and the sort of physical computations happening in these sort of electrical circuits, in some sense sitting inside our brains, then I think we would be closer to having a complete understanding of how language works. Thanks.
Okay, thank you, Sumit and Jay, for very thought-provoking ideas. To summarize very quickly um, from what I could understand, Jay was trying to talk about a minimal grammar, where the issue of modularity is not so much of a concern anymore, and he used the word modular isolation because initially we would have this language faculty, if we could still call it that, which was extremely modular. If also, I mean, it depends on what we mean by modular. If we were go with Fodor's usual definition of a modular system. So minimalism somewhere removes that modularity problem, that problem of not being able, of being very different from the rest of the modules, right, of the specific properties that we have. But I also did get a hint of skepticism in Jay's talk when he says that the brain sciences have not taken us to that level of understanding where we can start justifying our theories against or with whatever data or results we are getting from brain studies. So and then we had Sumit, who was much more positive, and established a possible connection, and showed us ways of having both. Um, so if you have a recursive system which is extremely minimalist, and then you also have a connectionist model where you can, which probably is at a different level of abstraction. Of course, we still need to explain the connection between those two levels of abstraction, right? So I thought that at least the tree that you showed at the end, where you had the synaptic models that showed you that, which you, I think you used the term layered, right? Layered neural networks. So maybe that's the way to go, and maybe that is the connection between the different levels of abstraction. So as a human chair, I'm going to reserve my right not to ask questions, right? So I'm going to open the floor now for discussion. Any questions you have, please, you're welcome to ask them, direct it to them, shoot your questions here, and they will answer. Again, there are, for the student presenters and the participants, there are no naive questions, right? And every question is equally relevant and thought-provoking, so please feel free. Okay, we'll pass the mic around.
So this is an extremely naive question directed specifically towards Dr. Sumit Agarwal. So you actually showed us logic gates and some weights associated with the gates. So would it be fair to uh, sort of like understand that these logic gates are kind of like innate, pre-wired or innately determined, while some algorithm is learning the weights? Is that how you would conceive of this system biologically?
Yeah, I think so. I mean, the thought is, yes, that those weights are something that you would be able to learn, and in fact, the main contribution of these kinds of models is that you have an algorithm, a process that allows you to learn those weights based on data that you are seeing. But uh, I mean, we also know that uh, connections between neurons can, be established anew. In fact, this is something that is happening throughout life in some sense. So, uh, so it's not necessarily the case that the structures even without the weights are kind of innate. I mean, what might be innate is certain kinds of uh, propensities for certain things to emerge possibly. Again, that is, I mean, all these are highly open questions, right? If you start thinking about what aspects of this kind of thing are in some sense innately determined and what are learned, I think we know very little about that. But we do have models where you can sort of vary the amount of innate component. You can have more or less innateness. So we can do that on a computer. What is actually there in the brain, I think we know very little about.
I have an observation, which is that these talks have been completely opposite to each other. I appreciate your positive uh, optimism, but there is nothing in common as far as I can see, because um, kind of stuff that your assumptions are quite different. So I think only at a very diplomatic level one can talk about similarities. For example, probabilistic determinism is a behaviorist model, or even pattern recognition. In the examples that you showed, the Iraqi bombing and the word mind, I need not have even seen any of those before. But the Chomskyan model would predict that you will be able to predict what's there without having experienced this ever. And there's scores of examples of that. We have something called parasitic gap construction, and that's just a very weird example, but there are many examples where people wouldn't have seen it or experienced it or heard it ever, but will be able to predict what it is. So there is no pattern recognition as such, because I think pattern recognition and probabilistic distribution are quite behaviorist, a remnant of behaviorism as far as I can see. Right at the first slide, there are things that you said which needs to be clarified. For example, you talked about language production. One needs to know what actually is production in this model. Do you mean by speech or behavior, or do you mean by generation of sentences? So if that's not clarified, then we don't see what is similar in these two kinds of ideas. Then you talked about, I think I noted down, yeah, some prior knowledge as innateness. But I think Raja is asking indirectly the same question, that how much of innateness? Some prior knowledge is it formalized in the connectionist model? As far as I know, it's not. And it's also something you said, that it's not FL, faculty of language is not something specialized. And also we heard about the summary that there is modularity is less the case. But I think modularity that Pritha was talking about is of a different type of modularity than Jay was talking about. Pritha is talking about the modularity in GB. It was highly modular in the sense that we have different principles within FL. That's gone. Those principles are gone. But I think there is modularity is still there, because these are like first factor, which is genetic endowment. Those are very specific language things. There are things like hierarchy, which is one of the basic properties. You don't see that in natural systems. You don't see in the cell structure, for example. There are things like long distance dependency, which we call agree, from two parts. We don't see it in gene structure. You don't see it in cell structure. You don't see it natural world. So there are this FL is, if you know the story, the Chomskyan story is something which is specific to language. So I think in I think third or fourth bullet point, you mentioned this modularity issue, which said that it's not language specific. Okay. So my end of it, I appreciate your optimism, but I think the assumptions are entirely different of these two models.
Yeah, so I mean, I'm sure there are lots of gaps which need to be filled in. Uh, yeah, my thought is just that in the commonality is that we are trying to think of ways in which these computations happen, which just generate. So again, I'm not when I was talking about production or whatever, the thought was just in terms of what generative grammars do, right? So not not sort of sound or anything like that. And yes, of course, there is a connection to behaviorism, as in, behaviorism was one place where some of these ideas were thought about. But at the same time, it's not having this kind of view doesn't imply that you are subscribing to behaviorism, because it's just to say that the lower level sort of structure must be like this. I mean, based on whatever we understand. So there are lots of gaps, right? But I'm just trying to say that these are some of the ways in which we might be able to link what we know about actual neurons and the way they work and the way they are connected up to each other to the the models that we have for language, which of course are not in any other way known to kind of be realizable in the brain, right? So that I guess I mean one problem with behaviorism probably was that it was uh, it was too low level in some sense, right? And it was not really allowing for or including within its framework uh, the the thought that the mind is kind of doing this symbol level computation, uh, and yeah, so I think there's no reason why you can't have both views of things and both of them being correct. It's just that they are at different levels of abstraction. So that really was all that I was trying to say, I guess, and just give some tentative examples as to directions you might move into to establish that more clearly.
Any questions?
Yeah, you want to ask a question?
There's one there. All right, where? Chetan?
Hi, I just want to ask, how would we incorporate grammatical judgment in the connectionist framework that if there is a synaptic weight attached to something, then ideally it should be either I can understand something or I can't. But there's a grammatical judgment about a sentence in that sense that something can be grammatical or not. How would we incorporate that in this framework? I was thinking, it might be stupid, I don't know. Uh, yeah.
No, 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 yeah.
Yeah, I think you could have that sort of thing quite easily. So uh, these kinds of models typically are sort of fleshed out with probabilistic inputs and outputs. So you would have some kind of distribution. So let's say you give a certain uh, sentence to a network that has been designed to recognize language, then it could give you an output which is, let's say, a probability between 0 and 1. So you could design that kind of network, right? And that output might be the probability of this sentence being a grammatical sentence, or how strongly you think this is grammatical. So yeah, so it's quite easy to combine these kinds of models with probabilities, which is one reason I think that makes them appealing. In fact, that I mean those examples I showed also about the noisy sort of tasks and how these networks can deal with them are to say that yeah, you have some missing information, but given the information that you have, you can still sort of probabilistically pick out that this is the uh, the the most likely answer for the missing information given the information you have. So yeah, so I think things like judging grammaticality or whatever could be happening in the same kind of way, that you have a kind of distribution, and also the fact that this could be highly subjective, right? So even though we all speak the same language, so we have the same sort of grammatical rules in some sense, but there often tend to be subtle differences, right? As in, I might say something one way and you might find another way slightly better. So possibly our internal kind of probabilities, which are based on the experience that we have had in terms of whatever we have listened to and read and so on, they will be very person specific, right? And there will be slight variations which may mean that our judgments of grammaticality are subjective. So I think this kind of model can account for that by having slightly different numbers and all these weights and so on, whereas the the sort of grammatical rules at a higher level of abstraction would of course be shared across everybody speaking the same language. But I think those person to person variations possibly are going to be captured if you think of it in this way.
Sir, one question to you, sir. So, a very naive, illiterate question. You said there are three factors which matter in minimalist theory now. One is language particular principles, interface conditions, and computational efficiency. And the focus is more on implementing computational efficiency when we are dealing with any kind of phenomenon. Why is it so that we want to focus more on computational efficiency rather than interface properties, which do also matter a lot? There's a lot of work going on in terms of interface conditions.
Well, why does emphasis tend to shift to the third factor?
Yeah. And not the second factor.
And not the second factor. Uh, 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 no.
Yeah.
Factor 2 is talking about the interface conditions. Okay, maybe there is only so much explanatory mileage you can get out of it. Is that possible? I don't know. But this, what Chomsky is trying to say is that the language particular things should be as minimal as possible, negligible, nil. Okay, but as you rightly say that the why are we emphasizing 3 rather than 2? That's what your question is, isn't it? My only off-the-cuff answer is maybe 2 hasn't yielded much explanatory mileage. You want to say something, Pritha?
Yeah, going by these factors. Well, very quickly, factor 2 is the experience part, where basically variation lies, which probably would be one of my questions once the others have asked theirs. So, factor 3 are the principles of other biological systems, architectural constraints that you find in the organic world. And that is where I think, once you start looking at those principles and saying whether they also apply on human language faculty, then you start basically saying, well, nothing really is different. So you may find specificities, but the language faculty is actually following those other principles that you find in the rest of the physical and the biological world. Yeah. So it's then you don't really need to be so specific anymore. I think that is what probably she was trying to ask, even though she also had an additional question whether we are also looking at the interface, because we did talk about you did talk about legibility conditions being driving the kind of outputs we are producing, right? So probably that is what she is trying to ask, that should we focus on interface conditions, so especially from the semantic.
There are two opportunities for explanation. Okay, the idea is that the principles of UG have to be explained away in terms of other things. That's why he says it is beyond explanatory adequate. That's how it becomes beyond explanatory. The UG principles have to be explained away, and one way to explain them away is in terms of interface conditions. Okay, another way is to explain it in terms of efficiency, and the maybe the third factor is a much deeper explanation, because it can go beyond the human organism to general biological principles. Okay, that is how neural networks are determined across organisms, different forms of life. So that kind of explanation would be a much deeper explanation.
So my doubt is regarding this, your remark regarding the explaining away of UG. So I'm just wondering if UG is completely explained away, is there any scope for linguistics as an autonomous discipline at all? Okay, this is become merely part of brain research or something of that sort. Linguistics as a discipline, would it survive? That is my main concern, because if there are only if language faculty is gone, maybe linguistics as a discipline doesn't have, we don't have much to do. Everything will have to be specified by the brain
work.
science. Okay. Yeah.
Yeah. Yes,
It is
precisely what
like
I was going to
endosa.
say.
Yeah.
That is that kind of apprehension is about whether chemistry, what happened to chemistry, because chemistry was finally explained away in terms of physics. But that doesn't really resulted in chemistry departments ceasing to exist. But what we did was we explained chemistry in a deeper way in terms of physics. That's why we're now talking about biolinguistics.
It's moving into biology. That is why
He has always
I
been.
feel it is very suicidal.
He's 85 years old.
Yes.
It hasn't come.
Yeah. Yes. That's right.
And Summer had a question.
So I had a question regarding basically the idea of computational complexity, and so I want to connect that with language variability. So if you have a systematic or a formal notion of computational complexity and saying that these kinds of configurations are complex, then why is it that we see some languages are better at those complex sentences while other languages are not? So the classic example would be Dutch versus German, where serial verb dependencies in Dutch are easily processed, whereas they are not in German. In German, embeddings are much more easily processed, and vice versa. So that's basically my question.
Would Chef want to answer that? I don't know whether I want to buy the idea of one language being intrinsically more complex than another. I don't buy that.
No, I'm not talking about one language being more complicated than the other. My question is, if one talks about universal notions of complexity, and the language or the theory talking about economy in computation, then how does it explain language variability, where one language has more complex structures and it easily processes them, whereas the other language cannot? So crossing dependencies, for example, right?
Processing thing, no?
Yeah, but that's, I mean,
Keep the divide.
Yeah.
Production versus comprehension.
right.
Yeah. Please.
No,
Something to say?
no, exactly what you said. Yeah,
Yeah.
yeah.
Yeah, so one of the things that worries me about giving up modularity is that this was not just a claim about how our brain is organized, our linguistic capacity was organized, but it also had strong methodological consequences. The methodological consequence being that we, as linguists, were actually studying possible and impossible sentence structures. As syntacticians and as phonologists, possible and impossible phonological structures. Now, what's happening in minimalism is that you mix at least two levels. So you mix the level of possible structure and the level of production and the level of comprehension. So the notion of phase, to my mind, is strongly a production and comprehension kind of notion, and it's not really a notion having to do with possible structures, right? So now, of course, it could be the case that that Chomsky is right, and that actually these production and comprehension factors are determining what the structures can look like. So my question is a methodological one. So is it actually true that we already understand enough of these separate levels to lump them together now, or would it be methodologically better to separate them just for methodological reasons because the various systems are too complex to study right now in each in interaction?
I don't know. That's an interesting question. That is, uh, you know, the separation of production and comprehension might be at a very deep level indefensible, because there is a sense in which, for example, when we see something, we are creating it. Okay, so are we comprehending an outside image, or are we projecting an image? So the same kind of thing might be happening in the case of language. That is, in comprehension, we are, and it has been noticed that that is, in comprehension, we subvocalize. So the mind is the mind of the receiver of a message is in a way replicating the movements of the producer of the utterance. So at that level, then, when you go at a subtler level, the distinction may not hold. I don't know whether I'm right or not. Yeah.
So if you have any more questions, please direct them to the speakers, and after that we'll go for a short tea break.
I have two questions. One is addressed to Jay, and another one is to Sumit. It is kind of in my desire to understand how much human intelligence can be, captured or artificially designed, taking language as part of that, and other human abilities as well. How much of to Jay, how much of the properties that we understand about human language or grammar is overlapped with other human abilities, in your opinion? And question to Sumit is, I just wanted to understand when you talk about probability uh, in a sentence or in language, which one will decide to have higher probability than the other? I mean, I just wanted to understand like what will decide, what is the factor for something to have higher probability than the other? Will it be like memory or something else? I mean, please.
So, by probability, do you mean the probability of producing something, or?
Yeah, in terms of language, say, you want to construct a sentence in your system. So, when you let's talk about merge, I merge something with something else, something should come up. So, when I have to merge it or something, like the way you were explaining the structure, what will decide something has higher probability than the other? I can understand, of course, in terms of threshold. If something has like 6, it will cross the threshold, so it will lead up. What will decide?
It's a selectional relation. There is a concept of head and head selecting.
Yeah, so you can have that. I mean, so of course the and or kind of examples I showed are just very simplistic examples. But so, and I think, I mean, Chetan's question also was related to this, right, in terms of judging grammaticality, for example. So again, you might have and there are various factors people study in relation to, let's say, production, where you might want to understand syntactic choice. So, you know, why do you favor something over another? Or, you know, given people, so people will do it in different ways. But if you look at the distribution across a population, you do have, you know, certain things being more probable than others, right? Certain kinds of sentences. So, yeah. So with these kinds of models, the thought would be that you would be able to tune the sort of weights so as to produce with greater probability certain kinds of things. And why would you do that is a separate question. I mean, so one possibility is that there's the kind of link between production and comprehension, so that you favor producing things that are easier to comprehend, right? So there's probably a kind of feedback between these two things, right? But what we are thinking of the system as doing is adapting itself to the data that it's getting from the environment. And if you have certain things that are more frequent than others, then it sort of learns to be able to produce those things uh, with a greater probability, right? So, and yeah, so you can have a mechanism where you I mean, all these models, basically you can specify the output as a distribution, right? So you have overall possible, let's say, sentences that express a certain thing. You have a probability distribution that comes from so giving the inputs, which are what is the thing that you want to say, you get a distribution over sentences. So that kind of thing is in fact typically that's the way these kinds of models would be set up, that you would have these probabilities at each node, kind of saying this is the distribution over outputs.
My question was, how much of the properties of language or grammar that we understand so far will be kind of similar with other general abilities of the brain?
Okay, my what Chomsky has always said is that this is an empirical question. So, no, I have a mic. This is an empirical question. How much of it is overlapping? The non-Chomskyan position of, I think maybe behaviorist approaches to language is that it completely overlaps. Okay, there is no difference at all in the language faculty, which cannot be explained in terms of general learning theories, etc. Which I don't know whether people still buy that kind of position. Otherwise, it is an empirical question. Chomsky would say it cannot be completely explained in terms of general learning theories. And if language is an instinct, if language making is an instinct of the human species, we have to look for the answers in that part of the brain where instincts are encoded. The instinct of a bird for making a nest. Where is it encoded in the brain? And I would think that it is encoded in the early part of the brain stem. And it always seems to me a bit, I mean, I'm confused about this. That is, the early part of the brain is evolutionarily earlier. Okay? And yet language evolved, emerged in evolutionary terms late. So that's a question I have still not answered.